Hello, this is Professor Teresa Pelkie. This is Session 7, Part 2, Aggregate Functions and Count. In this video, we'll be looking at some of the SQL functions that are usually referred to as aggregate functions. In the previous videos, we learned about functions. Those functions that we used are referred to as scalar functions. Note that scalar is spelled ending with L-A-R, not L-E-R. A scalar function is a function that takes 0 or more arguments and returns a value. A scalar function performs an action on each row independently of other rows. On this slide, you see an example of two scalar functions. The first function is the now function. That function does not take any arguments, and it returns the date and time. The second function is the concat function. With concat, you can specify one or more arguments. Each of the arguments for concat is concatenated together to produce the result. In this example, there are 3 arguments for the concat function: the name column, which is the city name, a single blank, and the district. You can see the results in the result grid. You see that the 2 functions are applied to each row in the grid. Each row has a value in the today's date column, which is the result of the now function. Each row also has a value in the name district column, which is the result of the concat function. In contrast to a scalar function, SQL also has aggregate functions. An aggregate function is applied to a column in all of the selected rows. The value that is returned from an aggregate function depends upon the column value that is in all of the selected rows. Keep in mind, a scalar function only works with a column value for a row. Scalar functions do not consider values in other rows to get the result. On this slide, you see the max function. That function takes one argument, which is the name of the column that you want the function to work with. In this example, we are finding the maximum or largest population of the cities that begin with the letter K. An aggregate function works in conjunction with the where clause, if there is one. The where clause determines if a row is included in the result set. In this case, the only rows that will be considered are those where the city name begins with K. Once the result set membership is determined, the max function is applied to the specified column over the result set. Aggregate functions are sometimes referred to as vector functions. The terms scalar and vector are the formal mathematical terms used in the formal definition of the SQL language. Most of the SQL functions that you'll use are scalar functions. There are only a few aggregate functions used with SQL. And here you see most of the aggregate functions all used on the same select statement. In this example, the functions are all using the same column, population. The functions are used to get the maximum population, the minimum population, the average population, and the sum of all the populations. Keep in mind, all of these aggregate functions apply only to the rows that are selected. In this example, the functions are only applied to the population values for cities that begin with the letter K. As you can see in this example, the aggregate functions are useful to get statistical data from a table. Now we'll take a look at something that you might think should work, but really doesn't. You'll see on this slide and the next 2 slides what the problem and the solution is. The question we are trying to answer with this select is what city that begins with the letter K has the largest population. Given that problem statement, you would think that the result should include the city name and the largest population value. When you hear largest, you might immediately think of using the aggregate function max. So your first impulse might be to write a select statement like this. At first glance, it works. It shows the city name and a nicely labeled max population column. But this is not right. Cobble A city in Afghanistan does not have a population of over 9 million people. So let's go back to a select that does not use the max function. Let's just take a look at the cities that begin with the letter K sorted in descending population order. You now see that Karachi in Pakistan is a city with a population over 9 million. Kabul is down in the list with a population of 1.78 million. So why did the previous slide show Kabul as the city with the largest population? It turns out that you can't specify a column name in the select column list when you are using aggregate functions. That is because as soon as you include an aggregate function, the function is applied to all of the rows in the result set. So on the previous slide, the max function did select the correct largest population value. But why did Kabul show up as the city name and not Karachi? When you use an aggregate function, SQL is not required to keep tracks of values in any other columns. To you as a human, it would seem to be an obvious thing to get the city name, but SQL does not make that connection. For example, if you used the average function instead of max and you included the name column, which city name should be shown? The name column does not make sense when used with average or sum functions. Since it doesn't make sense to allow other columns with those aggregate functions, SQL also does not try to apply any rules with max or min either. It turns out that Kabul was just the first city that was in the result set that the max function was applied to. Since the select statement did not specify that a name column was to be returned, SQL just picked out the first city name value that it found. You may think I'm making a big issue out of something that doesn't matter, but if you're just getting started with SQL, or if you don't remember how aggregate functions work, you might think that it was okay to write a select statement that includes a column and an aggregate function. This also shows that even when you get a result set that might at first seem to be okay, you need to check your data to verify the results. In this example, you can use a statement like what is shown on the slide to see the population values for the cities that begin with K. Using the result shown here, you can see that the previous slide's select is incorrect. But sometimes you will want to return a column name and a value like max or min. This slide shows how you can use the limit clause to get the city that begins with K that has the largest population. In this example, the order by clause specifies population in descending order. The limit 1 clause means that only the largest population value will be selected, which is what the max function would return. Because we are not using an aggregate function, we are free to include other column names in the select. So now we can include the city name column and get the valid result. Karachi is the largest city that begins with the letter K. To finish up with aggregate functions, we'll look at the count function. This function has two uses: to get the number of rows that are in the table or the result set, and to get the count of the number of values. In the top part of this slide, you see the count function used to get the number of rows. In this case, the count is the number of rows in the country table, since there is no where clause to limit the rows that will be included in the result set. There are 239 rows in the country table. The syntax for the count function is shown here. The word count, open parenthesis, asterisk character, closing parenthesis. It is very important that you use the asterisk character if your intention is to get the number of rows in the table or the result set. In the bottom left figure, you can see another usage of count. In this select, there are two count functions, one to get the count of rows in the result set, the other to get the count of independence year values using the column name INDEP year. Notice the difference in the counts. The row count is given as 239, but the in-depth count is given as 192. On the lower right, you can see an example of what is included in the country table. You can see that several of the in-depth year columns have a null value. When a column name is specified in the count function, the count is only for columns that have a non-null value. So that is why the in-depth count value is 192 and the row count is 239. There are over 40 countries in the table that have a null value for the independence year. In the next video, we'll look at the distinct keyword.